The reason I didn't want to rush through problem 28 is because there's several different ways to solve this problem. I want to talk about all of them. The model below represents the equation 3x plus 2 equals 2x plus 4. Remember, we used a scale model to represent an equation because whatever's on one side of the model equals whatever's on the other side if the equation is balanced. So the scale is like an equal sign. And on the left side we have 3x and 2 units, so plus 2. And on the right side we have 2x plus 4. And I think if they give you a picture like this, I think the easiest way to solve this is just take away these 2 units from the left side of the model. Remember, on an equation or a scale, you can take away from one side as long as you do the same thing to the other side. So if I take 2 away, cross off 2 from the left side, I have to cross off 2 on the right side. But now we have 3x's on this side, 2x's on the right side. So I'm going to subtract 2x's, or take 2x's off of the right side of the scale. And I can do that as long as I also take 2x's off the left side of the scale. And what we're left with is x, that's the only thing on the left side of the scale, x equals whatever's left on the right side of the scale, and the only thing on the right side of the scale is 2, so x equals 2. And that's the answer, x equals 2. But we would never stop there. We'd always plug it into the original equation to make sure it's true. The original equation was 3x plus 2 equals 2x plus 4. I'm going to substitute in my value for x equals 2, to make sure that that equation's true, or that value is correct. 3 times x, so 3 times 2 plus 2 should equal 2 times x, or 2 times 2 plus 4 if we have the correct value for x. 3 times 2 is 6 plus 2 equals 2 times 2 is 4 plus 4. 8 equals 8. That's true, so we know our value for x is correct. Another way to do a problem like this, especially on a tax test that's multiple choice, they give you 4 answer choices. You could try the different values for x in the original equation to see which one works. So just to illustrate that, let's try x equals 5, imagining that we were using that method and starting with answer choice F and working our way down. So I'm going to again rewrite the original equation, 3x plus 2 equals 2x plus 4. I'm going to substitute in x equals 5. 3 times 5 plus 2 equals 2 times 5 plus 4. 3 times 5 is 15 plus 2 equals 2 times 5 is 10 plus 4. 17 equals 14. 17 does not equal 14, and that's how we know x does not equal 5. And when you're checking an answer, if you get to a point like this and one side does not equal the other side, that's how you know you have the wrong value for x, and that's the whole reason for checking your value of x. If that happens, you go back to the starting point and try again until you figure out the correct value. Okay, that does it for problem 28. Pick up the tax test with problem 29 in the next video.